Once you understand how to create sketches in Solidworks, you can move on to use them as the foundation for three-dimensional features. Features are the 3D building blocks that make up the shape of a part. All parts, even complex-looking ones, are made up of a combination of features. Adding material with an extruded boss, making cutouts with an extruded cut, creating geometry by revolving a sketch around an axis. These are all examples of sketch-based features. In this section, we'll take a look at sketch-based features, or features that originate as sketches. For those of you who are new to 3D modeling, let's start by defining some terms. Extrude describes the process of taking a two-dimensional profile and making it 3D by giving it a thickness. A simple example of this would be taking a circle and making it into a cylinder. The term boss, as used in SolidWorks, describes any piece of solid geometry. Think of a boss as the opposite of a cut or hole. The extruded boss feature can be selected from the extruded boss/base icon in the command manager, or selecting it from the insert drop-down menu under boss/base, or I can use the S key shortcut menu. I'll select a plane to sketch on, and then create the two-dimensional sketch using the sketch tools you just learned about. This sketch will serve as our two-dimensional profile. The shape of the sketch is not important. Almost any sketch can be used to create an extruded boss. Once a sketch is completed, simply exit the sketch by using this icon here, or right-clicking and selecting Exit Sketch. Alternatively, you can also switch to the feature icons in the command manager and reselect the extruded boss/base icon. All of these methods make the extrude property manager appear. These are the properties of the extruded boss. The most obvious control we have here is the spin box that controls the depth of the extrusion. Here, you can use the up and down arrows to specify a value for the depth. As I make adjustments, notice the preview continually updates. If I type in a value instead of using the arrows, I have to click somewhere outside the spin box in order for the preview to update, or press the Enter key on the keyboard. As I changed the value for the depth, you may have noticed that the material is being added to the left side of the sketch. You can change that by using this button. You can also use this arrow as a handle to drag the material from one side to the other. As I do this, notice the value of the depth is also changing. If I hover my cursor directly over the ruler while I drag the arrow, it snaps to defined values. These arrows, or drag handles as they are referred to in SolidWorks, can be helpful when you are working on a design concept. If you don't have an exact depth in mind, this is a quick and easy way to explore different scenarios. There are different end conditions you can use with the extruded boss. Currently, the end condition is set to blind. Blind simply means you want to take your profile and extrude it in a single direction using a specified depth. Other end conditions can be related to surrounding geometry, such as up to vertex, up to surface, offset from surface, and up to body. Next to blind, the most common end condition is mid-plane. This is similar to blind, except that material is added to each side of the sketch. When using mid-plane, the value for the depth represents the total depth. SolidWorks will take care of splitting half to each side. By default, an extrude will extend normal to the sketch it is based on. This option here, called Direction of Extrusion, will allow you to change the direction of extrusion based on the type of item input into this field. We'll skip this option for right now and return to it in the part lessons. If you have the need to add more material to one side of the sketch than the other, you can activate Direction 2. This allows you to specify a unique depth or even a different end condition for each direction. There are a couple more options we'll look at in a moment. For now, I want to finish the extrude command. To accept these settings and finish the command, I can use the green check here, or here. I can also right-click on the graphics area. Finally, I can also press Enter on the keyboard. All of these methods of finishing a command will be available with most features in SolidWorks. I'll be using one of the check marks so you can see what I'm doing, but any method you're comfortable with will work just fine. Take a look at the window on the left. It is switched from the property manager for the extrude command to display the feature manager tree. Notice the feature extrude 1 listed here. This represents the extruded boss I just created. Every feature you create as you build a part is going to be listed here. This is important because this list will give you access to features in case you need to make changes. For example, if I want to change the depth of this extrude, I'll simply select the feature here in the Feature Manager design tree and select Edit Feature. These are the settings I used to create the extrude. I can change the depth, press the green check, and right away the change takes effect. By clicking the arrow here, I can also see the sketch that was used in creating the extrude. If changes to the sketch are required, I can click on the sketch and select Edit Sketch. This brings me right back to the Edit Sketch mode where I can make changes, such as adding dimensions. When I exit the sketch, the changes take effect immediately. Another technique for making changes to dimensions is to simply double-click a face belonging to a feature. When I do this, all dimensions associated with the feature become visible. The black dimensions belong to the sketch for this feature, and the blue dimensions belong to the 3D feature itself. Once the dimensions are visible, I can double-click them and make changes. To update the model, I'll simply rebuild it by clicking the icon right up here. The next feature we'll look at is the extruded cut. This feature works exactly the same way as the extruded boss, except it removes material instead of adding material. Like the extruded boss, the profile for the extruded cut is defined in a sketch. The command can be launched from the drop-down menu, or by using the extruded cut icon in the command manager, which shows a box with a hole in it, and of course, it's found in the S key shortcut menu as well. When using this command, I suggest you change to an isometric view so you can clearly see the direction of the cut. Otherwise, you may be surprised at the result. Notice the properties available for the extruded cut are almost identical to those of the extruded boss, with a few differences in the end conditions available. The Through All option allows you to create cuts that go through the entire part in one direction, without having to type in the thickness of the material you are cutting. Through All Both creates an extruded cut in two directions. Notice that with Through All Both, the end condition for direction 2 was automatically set. A nice benefit of using the Through All end conditions is that even if the thickness of the part changes, the cut will still go through the entire part. Be careful though, you don't want to cut away material accidentally. If you want to change the end condition for direction 2, all you have to do is select a different end condition from the dropdown. I'll click Blind, and notice the end condition for direction 1 updated to Through All. In addition to using a closed sketch to create the cut, as I have done here, you can also use an open profile. I'll sketch an open profile on the outside face of the block. Making sure the sketch intersects the edge of the part on either side. And launch the extruded cut feature. You can see that Solidworks extends the sketch in both directions to create the cut. Any geometry on this side of the sketch will be completely cut away, as indicated by the arrow. If I want to cut away the other side of the block, I can click the arrow in the graphics window to change the direction, or check the Flip Side to Cut option in the Property Manager. When I click OK, you can see that the open profile cut is created. Before I wrap up, I'd also like to mention that if you're working in SolidWorks 2015 or later, you can also apply a blind end condition to an open profile cut, just like an extruded cut created with a closed profile. There are a few more options that are available in all sketch-based features. One of them is the use of selected contours. This option allows you to choose specific portions of a sketch to be used in a feature. For example, in this sketch, I can choose only the circular profile, or only the rectangular profile. Selected contours make it easy to use only the parts of a sketch that are important. With selected contours enabled, I don't necessarily have to pick a profile. I can also pick regions of a sketch. Any combination of profiles and regions will work just fine. I'll select these contours. Another useful option is Thin feature. This option will allow you to extrude a profile as a thin wall instead of a solid. Once Thin feature is activated, you can control the thickness of the wall, the direction of the thickness, and the way the thickness is defined. The midplane option distributes the wall thickness equally to both sides of the profile, while two direction gives you independent control over the inner and outer wall thickness. You also have the option to cap the ends of the Thin feature. With this option enabled, the Thin feature is capped at each end, creating a hollow body. You can adjust the thickness of the caps with this spin box here. Additionally, you can create a Thin feature using multiple contours all at once. For example, here I have a simple part, and I have a sketch on this face that contains 3 arcs that I'd like to cut into the part. I'll just launch the Cut Extrude feature and select the sketch containing the 3 arcs. The Cut Extrude property manager appears with the thin feature already checked. I'll choose the mid-plane option, so these arcs will represent the center lines of the cut, and I'll enter a value of 0.25 for the thickness. You can choose to automatically add fillets to the corners, but I'll leave the checkbox cleared. Notice the preview on the graphics area shows all of the contours already selected, but you can adjust which contours you'd like to include in the cut by using the Selected Contours section at the bottom of the Property Manager. One thing to keep in mind here is when you create a thin extrude using multiple contours, they must all have the same end condition. If you need a different end condition or depth for each contour, you'll have to create them separately, just like you would before. In this case, I'll use a blind end condition, enter a depth, and when I click the green check, the feature is complete. The revolved boss allows you to take a 2-dimensional profile and revolve it about a center line to create 3D geometry. Shapes that are axially symmetric, like this baseball bat and this chess piece, for instance, can easily be created with a revolved boss. The revolved boss command can be launched using the icon here, or from the drop-down menu. Next, select the sketch plane and create the profile for the revolve feature. Upon exiting the sketch, you will see the properties available for a revolved boss. The first selection box requires you to select the sketch line, or the edge of geometry, as an axis of revolution. If you have a single center line in the sketch for your axis of revolution, Solidworks will automatically select the center line for the axis of revolution. If you would prefer to use a different sketch segment that is not a center line as the axis of revolution, you will have to activate the selection box by clicking in it, then selecting the sketch segment. The degrees of revolution can be specified in this spin box by using the arrows or typing in a value directly. This value can also be changed by using the drag handle in the graphics area. If I drag the handle completely around, the direction of the revolve changes. The direction can also be changed from clockwise to counterclockwise by pressing this button. It is also possible to specify a couple of different revolve types, like we've seen in the extrude feature: up to vertex, up to surface, offset from surface, and mid-plane. You can also activate the Direction To box to apply a different angle on the opposite side of the profile sketch. The Thin feature and Selected Contours options can be used here, very much like we saw earlier with the extruded boss. To finish the revolved boss, you simply click the green check, and you're done. The revolved cut works just like the revolved boss, except the end result is the removal of material. In this example, I'll use a circular sketch as the profile for the revolved cut, and revolve it around this center line. I'll launch the revolved cut feature from the command manager, and the Cut Revolve property manager appears. The center line is automatically selected as the axis of revolution. And just like with the revolved boss feature, options are available for the end condition and degrees of revolution, as well as for Direction To, Thin feature, and Selected Contours. I'll leave the options at their defaults, click the green check, and the revolved cut is complete. The Sweep is another feature available for creating and removing material in SolidWorks. Generally, the sweep is used to create geometry that is more complex than what can be created with extruded and revolved features. The main difference between the sweep and the previous features that we've seen is that instead of extruding or revolving a single sketch, a sweep uses both a profile and a path. A sweep takes a profile, such as this half-circle sketch, and sweeps it along a path, like this curved sketch here. For the profile of a sweep, you can choose a face from model geometry, model edges that make up a smooth closed loop, or a closed sketch that doesn't intersect itself. For the path, you can use a sketch, a curve, or the edges of an existing model. You can see that in this example, the profile sketch was created in the front plane, perpendicular to the top plane where the path has been created. In addition, the profile is centered on the endpoint of the sweep path. This is one of the most common ways to set up a sweep, because it allows you to use the path as a center line for the profile. You don't have to center the profile on the path, or even create these two sketches perfectly perpendicular to each other. But for now, we'll just focus on the most common sweep methods. For a more detailed look at advanced sweep capabilities, check out the Advanced Parts course. Let's get started creating a simple sweep. I'll start a new part. And you can see that currently, the sweep icon on the command manager is grayed out. This is because currently no sketches exist. I'll create the sketches for the profile and the path before I proceed. I'll start a sketch on the front plane. I'll launch the Center Point Art tool from the Sketch tab and center it on the origin. Next, I'll launch the Line tool and close off this shape. This will be my profile sketch, or the sketch that is swept along the path. I'll exit the sketch and start a new one on the top plane, which is perpendicular to the front plane where I just sketched the profile. I'll sketch a straight line that goes through the center of the profile sketch, and use auto transition to create two connecting arcs. And complete it with a straight line segment. I'll exit the sketch. Now, on the command manager, you'll see the sweep feature is available. I can use the icon here, or go to Insert, Boss/Base, Sweep to launch the command. As with other features, the property manager shows the various settings and options for the sweep feature. Like I mentioned earlier, many of these are beyond the scope of the course, so I'll just go over the most essential ones here. The first option you have is whether to create the sweep with a sketch profile or a circular profile. I'll start by using the sketch profile option, and show you how to use the circular profile option in the next lesson. With this option enabled, you will see two selection boxes. This is where you define the profile and the path. It doesn't matter which you pick first. Just make sure that when choosing the profile or the path, the corresponding selection box is active. I'll enable the profile selection box and pick the arc-shaped sketch from either the graphics window or the flyout feature manager tree. When I do, the path selection box automatically becomes active, and I can select the path sketch. If the Show Preview option is checked, you will immediately see a preview of the resulting sweep. You can see how the arc-shaped profile sketch has been swept along the path sketch, creating this curvy rectangular body. Under the Options section, you can set the profile orientation to control the direction of the profile as it moves along the path. Right now, it is set to Follow Path, which causes the profile to turn as it is swept along the curves of the sketch. You can also choose Keep Normal Constant to keep the profile aligned in its original orientation at every point along the path. In this example, I'll use Follow Path. I'll skip the rest of the options for now, click OK, and the sweep is created. If I expand the sweep feature, you can see the sketches that make up the sweep are contained within. One of the most common kinds of sweeps is a sweep with a circular profile. Circular profile sweeps are frequently used to model rods, pipes, tubing, and more. Since they are so common, the ability to use a circular profile was built directly into the sweep feature, allowing you to bypass the step of creating a profile sketch. Let's take a look at how it works. I'll delete the existing sweep feature, and you can see that the sketches still exist. I'll click on the profile sketch, and from the pop-up toolbar, click the Hide icon. I'm going to reuse the path sketch. I'll launch the sweep feature, and this time I'll create the sweep using the circular profile option. When I enable this option, you'll see that the selection box for the profile sketch disappears, and now there is only a place to select the path. I'll select the path sketch from the graphics window. Underneath the path sketch selection box, you can define the size of the circle that will be used as the profile. I'll enter a diameter of 1 inch. When I click OK, you can see that the circular profile sweep was created without having to create a profile sketch. If you want to use a sweep to model a pipe or tube, you don't need to go back and sketch a new hollowed-out profile. Instead, you can simply create a thin feature within the sweep, just as you would in an extruded boss or cut feature. A thin feature can be created using either the sketch profile or circular profile options. I'll delete the sweep and recreate it. This time, I'll select the thin feature option and set the end condition, direction, and thickness of the thin feature. I'll click OK, and the thin feature sweep has been created. You can also create sweeps by using model geometry, such as faces, edges, and curves. I'll create a sketch normal to this face, and activate the sweep feature. In the Property Manager, I'll select the face as the profile, and the sketch as the path. I'll click OK, and you can see the newly created sweep. Like the sweep, the loft feature is useful in creating geometry that is difficult, if not impossible, to create with extruded and revolved features. Also, like the sweep, the loft requires at least 2 separate sketches to create. The main difference between the loft and the sweep is that the loft creates a transition between different shape cross-sections, like the rectangle and circle you see here. Before I can use the loft feature, I need to have 2 sketches. I'll go ahead and create the first sketch on the top plane. I'll sketch a rectangle and exit the sketch. To create the second sketch, I'll first create a plane that is offset from the top plane. The subject of creating planes is discussed in detail in the Applied Features section of this course. For now, I'll quickly create a plane by pressing the Control key and dragging the top plane up. I'll enter an offset value and click OK. On this new plane, I'll sketch a circle and exit the sketch. I can now select the Loft command from the Features tab, or from the Insert drop-down menu under Boss Base. I'll click it, and the Loft Property Manager appears. In the Profiles selection box, you can select the profiles you want to use for the loft. I'll select each sketch, and you can see a preview of the resulting loft. For now, I'll leave the rest of the options at the default. Click OK, and you can see how the loft feature created a transition between the profiles. If the shape of the transition isn't important in your design, using the default settings can be a convenient way to create a simple loft between profiles. Otherwise, there are many more options when creating a loft that control its shape. And while most are beyond the scope of this course, there are a few you need to know. Let me edit the loft feature. The start and end constraints can have a significant effect on the shape of the loft by controlling tangency at the start and end profiles. Let me show you what I mean. I'll select Normal Profile for the start constraint. In the graphics window, you can see the preview updates. An arrow appears normal to the starting profile, and you can see the shape of the loft at this end is now tangent to the arrow. I can change the tangent length by dragging the arrow, or by entering a value here, or reverse the tangent direction by clicking this. I can also add a constraint to the end profile to independently control the tangency at the other end of the loft. In the graphics area, you'll notice 2 connector points, one on each loft section, with a line running between them. This represents the path that the loft travels. If I drag the connectors to change the path, you can see how the geometry is affected. If I drag the connectors too far, the preview disappears, and the loft can't be created. If you ever encounter this error, try adjusting the connectors until the preview reappears. You can also add connectors to the loft to give you additional control of its shape by right-clicking on a profile and selecting Add Connector. Before I wrap up, I want you to be aware of one last option here: Close Loft. This is a useful option when you want to create a loft that results in a closed shape. Here, I have 4 individual sketches. As I pick each sketch to be used as a profile for the loft, you can see the preview updating. However, I want this loft to close on itself to form a ring. If I try to pick the first profile again, instead of closing the shape, this profile will be unselected. The proper way to close the loft is to first pick all the profiles. Then use the Close Loft checkbox in the Property Manager. I'll click OK, and here is the result I was looking for. Ribs are another sketch-based feature that you can create in Solidworks. Just like any other sketch-based feature, a rib requires a 2D sketch. I'm going to choose the top face of this model as my sketch plane. Notice that I'm only sketching a single line. This is all you need for creating a rib. The other thing to note is that the endpoints of the line do not have to connect to the surrounding geometry. Solidworks will automatically extend the rib to the surrounding features or faces. Once the sketch is finished, I can start the rib command by selecting it from the Insert drop-down menu, under Features. Or I can click the rib icon on the Command Manager on the Features tab. This opens the Rib Property Manager. Here, you can edit things like the rib's thickness, extrusion direction, or add a draft. When specifying the thickness, you can add the rib material to either side of my sketch line, or you can add it evenly to both sides. I'll add it evenly to both sides. Next, we can choose the extrusion direction and its orientation. Notice the direction of the arrow as I select between parallel and normal to sketch. Make sure the arrow is facing in the direction you want to add material. In this example, I'll extrude the rib to be normal to the sketch, and I'll want the direction arrow to face the model. If the arrow is facing in the correct orientation, but is facing the wrong direction, you can use the Flip Direction checkbox to point it towards the part or away from it. If I wanted to add a draft, I could simply click the draft icon and enter a degree value. But we'll skip that for this example. To finish up, I'll click the green check and the rib will be added. Let's look at another example using the Parallel to Sketch option instead of the Normal to Sketch option we just used. For this example, I'll select the right plane as the sketch plane for the rib. And again, I'll sketch a single line. I'll continue by clicking the rib icon to bring up the Rib Property Manager. For the extrusion direction, I want to make sure the arrow points towards the rest of the part geometry by using the Parallel to Sketch option. Notice the direction that the arrow is facing with this option. Last time, with the Normal to Sketch option, the arrow was either pointing directly towards us or directly away from us. Remember, the arrow should point in the direction where we want to add material. I'll add material evenly to both sides with a thickness of 0.10 and finish up by clicking OK. Let's go through one more example, except this time we'll use a more complex sketch. For this example, I've already created this sketch that has a couple lines and a circle on a plane that was offset from the top surface of this model to be used for a rib feature. I'll click the rib icon. Just like before, I'll give it a thickness of 0.10 and add it on both sides of the sketch segments. I want the arrow to face towards the model, so the extrusion direction should be normal to sketch. I'll click the green check to finish up, and the rib is added.